Okay, so I go to my flashcard deck. If I have one written on the board yet. Here we go. So I've got to have that flashcard. How many would have said what Julia said? 22 for Julia. Let's give people a chance to make the card. Okay, cool. So I go back here. So I have apps to find F prime. Does anyone need more detail on that stuff? Just wave at me if you need more detail. The goal, listen, the goal here is to figure out at what values of x will f prime equal 0. At what values of x will f prime equal 0? Question for the whole room. Comment first. Look, at this point in the year, you really aren't learning a whole lot of new things. You're just learning to apply rules and concepts to new situations. So if it feels like I'm really redundant, it's because I am. But what is causing a lot of people to get stuck on problems is not being quite good enough with some really, really basic ideas that just keep showing up over and over. For example, when you see this equation, please raise your hand if you can tell me how many things in this equation are considered variables or unknowns. Hands up. 1, 2, 3, 4. How many things in this equation would be considered to be a variable or an unknown? Hands up, come on. Feel free to talk to each other. So hands up again, how many? Hands up, hands up, hands up. How many are considered variables or unknowns? Let's go, Brianna. So what would you consider to be the variable, Brianna? So Brianna's voting that X is an unknown. Good answer, totally true. The thing a lot of people miss is this is also an unknown. So there are two symbols we don't know. There's X, which is just an X coordinate, and there's F prime, which is the slope of F at any X coordinate. So 2 points for Brianna. How many knew there were two unknowns in this problem? Point. Okay. Look at me. Look. No one talk. Look at me. Concentrate. Okay. The concept I'm presently describing is one that many people get stuck on because it's so simple. They, like when I start talking about it, they kind of check out and, oh, I already know that. But then when you encounter it in a problem, you can't use it correctly, so you get stuck. You use this equation. We use, like pretty much every equation we have in this class has to be used two ways. You have to be comfortable using the equation both ways. The common thing to do is to know an X coordinate, plug in the X, run the computation, and find a value of F prime, meaning a slope on F. But the other way you have to use the equation is the other way around. You have to say, in this situation, I know the slope I'm looking for is 0. I need to know what X coordinates cause that to happen. So I'm going to write on my paper 0 equals. And then I have all this stuff, let's rewrite that again. Okay, I'm being really serious. This idea of knowing that I should put a 0 here and knowing why I do it has caused hundreds of students to lose points on tests because it just never occurred to them that you could take this similar way and put in a 0. Like they'll just stare at the problem, I don't know what to do. Like you have to recognize pretty much every equation we use in this class can be used 2 ways. Way with me, we need to talk more about that. It's super fundamental. So you need to talk more about how to help.
When like I get when it can be used as 0, I just don't get when it can be used. Like
So
how do you know which?
You're good. Let's just back up a step. So what's the goal of the problem?
How many critical points?
Don't say that.
Sorry, how many critical points does function f x?
Good. So we're finding how many critical points f has. So what is the indication that f will have a critical point? So you gotta go back to the flashcard again.
Yeah.
So what's the indication when f has a critical point?
Oh, it's when f is equal to 0.
Right, so we're looking to see when f prime has a value of 0. So that's specifically why, so equal, man alive, this is terrible. Look, equal means these are the same. Like equal doesn't mean the answer to f prime is 0. It never means that. It means they're the same thing. Like I hate that in elementary school they do this. They go, oh, the answer is 9. No, there's no answer. There's no answers in math ever. It's like there's just, we're solving a problem and we see how things relate. These are the same thing. This isn't equaling this. It's like these are the same. So you can substitute. So anywhere I see this, I can put in a 0 instead. That's what I want to have happen for the else. Okay, another thing that will happen repeatedly. It's going to be very exciting day. Another thing that will happen over and over again is you have an equation like this that seems impossible to solve. Okay? You have to remember to factor. If you factor, it becomes much easier to solve almost always. So please raise your hand if you know what will factor from this. Hands, come on. I'm going to give a hint. Keep your hands up. If you're having trouble with factoring, here's usually the reason. You must first look at the expression and be able to identify that you have multiple terms. So hands down for a second. Go like this. Show me on your hand without showing everyone else. How many, okay, the trouble with the word term and factor is kind of changes depending on my perspective. When I look at this entire expression, I see a certain number of terms. Show me on your hand how many terms you see. 1, 2, 3, 4, 5. Show me. How many terms do you see? Term means you see a chunk, plus a chunk, plus a chunk, plus a chunk. That's what you see when you talk about terms. Natalie has the same disease I have. Everyone give yourself 2 points for voting. There are 2 terms. Look. When I look at the entire expression, there are 2 terms. There's this big term, and then there's this big term. Now, the reason the word term is tricky is because within this term, I can see other terms. And show me again. Inside this term, how many terms do you see? Term means you see things being added. So in just this piece, can you see any terms? I do. I can see terms inside that piece. Show me in your hand. We got everybody mixed up. Point to the room. Look, if I'm looking at this, I could say, hey, here's a term plus a term. For sure. Here's another term plus a term. So the word term changes depending on your perspective. You could also look at this and say, this is really x minus 3 times x minus 3 times x minus 3 times x minus 3. There's freaking 8 terms right there. Okay? Understand? Not if that makes sense. Okay, please.
Could 5 even be a term? Because it could be just 5 plus 0 or 5 minus 0.
You could extend it that way. We won't in this class, just because we haven't found that to be useful, but the thinking is good. 2 points. So are you with me? Okay, when you look to factor, first thing is you look at the entire expression and see if you can identify like big terms. There are 2 of them. okay? Then you look at each term and you say, what are the factors which multiply to create the term? You try to identify factors that are present in both terms. So hands up, who can see the factors that are present in both terms? Come on. You've got to learn to think with me in this class. You cannot just watch. You've got to think with me. You just got to get willing to raise your hand and say, I'm going to take a chance and say, I think it's this. Natalie? Good. So Natalie, how many factors of x minus 3 are in both of them? Now I said that in a way that might be confusing. Yeah, no, you're doing fine. What I meant to say is, how many factors of x minus 3 do you see here?
4.
Good. How many do you see here?
3.
Perfect. So we can take out 3. I didn't ask the question. So how many knew what she was going to say? Point 2 for Natalie. Sorry about that. You did it really well. So we've got x minus 3. Cute. What other factors are present in both terms? Hands up, come on. What other factors are present in both terms? Let's go Ty.
Plus 2.
And how many are present in both? 4. Good work. Okay, raise your hand if you knew I was going to do that. Point 2 for Ty. Hands up again. Oh, please.
I'm a little confused how you got from 4 and 3 to just 3. Like for x minus 3, like.
From here to here.
Yeah.
What we're doing is we're saying this is really x minus 3 times x minus 3 times x minus 3 times x minus 3 times 5 times x plus 2 times x plus 2 times that. This is similar. So we are going to literally take out of this factor 3 of the x minus 3.
So we have 1.
So we're going to have 1 remaining.
Yeah, I get that.
You're good. Question? Class, raise your hand if you know what gets written here. Come on, show me your hand. What gets written here, Devin?
X plus 2.
Anything else? Devin? 4. How many do it? Point 2 for Devin. Question? Something I say all the time, I'm just going to keep saying it. You've got to get away from just doing stuff to understanding what you're doing. Like, you cannot succeed on this test by just doing stuff. You got to know why you're doing it and understand it. Is that any good? Cool. Okay. I would not call what I'm about to say a math rule. It's just I've learned from experience. Okay? I've learned from experience that when I see an expression that consists of x, constants, maybe x squared, that what will be best is to multiply this all out and just get something that's simpler. So I just know that from experience. So if you can't remember that, make a flashcard to remind yourself. You see something like this, you should just multiply it all out. So, question. Okay, another common problem that occurs is you'll get so busy doing steps you lose track of the problem. So practice, do some steps, think of the whole problem. So I started out finding a derivative, and then I thought of the whole problem again and said, oh, I've got to figure out when the value of the derivative is 0. That's the goal. And what x will make the derivative 0. And then I remember solving something like this is pretty much impossible unless I factor. So I factored. Now that I'm done factoring, it's time to look at the big picture again. So hands up, what's the big picture? What's the goal? Could you say in words what we are trying to accomplish? More hands? Like a few more hands, please talk to each other. More hands. What's the goal? So hands up, who knows the goal? What's the goal? Come on. So what is the goal of the problem? And how do we find the critical points of that? Right, so we're right here in a really good spot. You're trying to figure out what x will make all of this 0. And I believe the mathematical word, you don't need to memorize this, but maybe it helps you, is we are now looking at what's known as the 0 property of multiplication. Because I have a factor times a factor times a factor. And it has to equal 0. So what has to be true of the factors? Pardon?
There's only 3 of them, or there's only going to be 3 zeros for that.
Only 3 zeros. Now remember, in this equation, x doesn't take on multiple values all at once. It's like you say, okay, let's choose x to equal 3. That literally means we put a 3 here, here, and here. But very quickly we say, who cares what this is? Because this will be 0. That's the 0 property. So I know that when x equals 3, f prime of 3 will be 0. Therefore, at x equals 3, f has a critical point. Questions?
So does this method work for like all of the problems where you end up with a really ugly equation when you're trying to do the sine pattern chart?
So, I cannot guarantee that when you're trying to figure out, what x will make an equation equal 0, that factoring will always work. I can't give you that as a guarantee. I can tell you that based on my experience on the AB test, it probably works about 96% of the time, maybe 97. So it's a very, very reliable method. I just can't say it's perfect. Please.
We did 9, not 16.
What's that?
We did 9, not 16.
Oh, thank you. So one of the critical points occurs at x equals 3. Raise your hand if you know where the other 2 critical points occur. And what x coordinate does the other 2 critical points occur? Let's go, Derek.
7/9 and -2.
Good. So x equals 7/9. How do you do it? 2 points. 3 for Derek. Question? The answer is 3.
Is it -2 or true?
Oh, my mistake. 2 for Savannah. Please.
I'm just a little bit confused on this.
7/9. Are you comfortable that if we can find an x that will make this 0, it won't matter what's happening here? Same for here. So we're looking at this one. We're trying to figure out what x will make this 0. So just do a little algebra. We want to know 9x minus 7 needs to be 0. So move the 7 over.